Hi Geometry, hopefully you are surviving these rainstorms. It was hailing earlier today. JD is up north somewhere. Hopefully it's not raining up there. Enjoy yourself. We are now doing 2.4, use postulates and diagrams. Okay, now we're starting to get into the geometry stuff, but still not quite a proof. You'll understand when we get there. Our learning targets, I can use postulates involving points, lines, and planes, and I can use postulates involving angle and segment measures. So now we're going to start getting to some of the postulates or rules that we're going to be using, and every time you make a step in geometry, you have to list that rule. So here we go. In geometry, rules that are accepted without proof are called postulates or axioms. Rules that are proved are called theorems. Okay? So we will be proving theorems. Every time you get a theorem, it's either going to be proved in the book or as a homework assignment. Alright, so first of all, you have already learned 4 postulates. Draw a picture illustrating the postulate. So the ruler postulate. So this was page 9 in your book, I believe, and basically it's about distance. Hopefully you can see that. I wonder if I should use the black pen. And we're going to draw a picture, so basically here's A, here's B, x1, x2. The distance AB is equal to the absolute value of x2 minus x1, because a distance always has to have a positive value. Okay. Postulate number 2, I believe this is page 10 in your book. So segment addition postulate. I'm going to draw a picture. So we have A, B, and C. A, B, and C on this line. And basically, if you take this distance, which is AB, and this distance, which is BC, it's going to equal the whole distance. So AB plus BC is equal to AC. Of course, you can also find parts by subtracting. If you have AC and you know AB or BC, you can find the other one. Protractor postulate. I believe this is page 24 of your book. JD, again, you will have a different book, so be careful with that. We'll have to look that up. Alright, so let's say you have a protractor and we have some angle. We're going to have this O, this will be B, this will be A. Okay, and we're looking for this angle, this arc from A to B. So it's a measure of the angle. Okay, and angle addition postulate, page 25, basically take 2 angles, add them up. Let's see, we have RST. This is just our warm-up. Don't you love it? And we'll put P right here in the center. If we have the measure of angle RST, that whole angle, is equal to the measure of the top angle plus the measure of the bottom angle. So the measure of angle RSP plus the bottom angle is PST. And again, I like to put little arcs here for the angles. Okay, so that was just our warm-up. We've already done a couple. Now let's start adding on to them. Okay, so postulates 5 through 11. I believe this is like page 88. So I have to double check these to make sure. Postulate 5, it's the 2-point postulate. Through any 2 points exists exactly one line. I know it seems obvious, and there's a reason why we're not proving it, so we accept these. Line point postulate, a line contains at least 2 points. Line intersection postulate, if 2 points, I think I have a mistake here, if 2 lines intersect, they intersect in 1 point. 3-point postulate, through any 3 non-collinear points there's exactly 1 plane. A plane contains at least 3 non-collinear points. If 2 points lie in a plane, then the line containing them lies in the plane. Should still be obvious. And plane intersection postulate, two planes intersect, their intersection is a line. So we've actually discussed all these, but now they're just listed as postulates. And let's use that information. Okay, so we're going to use this picture here and write examples of each postulate. So the 2-point postulate, basically CH, 2 points. It's going to make a line. Okay, the line point postulate, it's postulate 6. Remember, a line contains at least 2 points. It could be like line L, CCL. Pick line L because there's lots of points. Line intersection postulate. So if you have two lines that intersect at one point, that would be at point D. 3-point postulate. Through any non-3 collinear points, there exists one plane. So you can pick any 3 points. We can do plane. Let's see if you can guess the same points I'll pick. Plane CDF. Pick these 3. And plane point postulate. A plane contains at least 3 non-collinear points. Basically, plane M. And plane line postulates. So let's see here, plane line. 2 points line a plane, then their line also is in that plane. Okay, so we could just do line CD. Is on plane M. Did I not have? I didn't do postulate 11. Oh, I think it's because of a space issue. In any case, example 2. Sketch a diagram of the description. So GH intersecting XY. Oh, you can't see that. At point A in plane Q. Alright, so let's just make a plane Q. We'll call it Q. And then we have GH. And it intersects XY. Nice straight line, huh? At point A. It's not that hard. Alright? Put an arrow there. ST bisected UV. Let's see here. At point V in plane R. Okay, so we have another plane. Remember, planes go on forever. Call this plane R. So we have ST bisected UV. So let's draw UV. Okay, let's see here. This doesn't make a lot of sense. ST bisected by UV at point V. Okay, so ST we have to cut in half. So let's say that this segment is the same as this segment. ST. Okay, so this length has to be the same as that length. Alright, it does make sense. And plane C and plane D intersect. I hate drawing these. Okay, let's try it. Let's see. I need a plane C and a plane D. It's intersecting. That's pretty bad. Intersecting at this line right here. And that would kind of call it AB. And this is plane, let's see here. We also, we'll say E is on that line. Call this plane D. Yeah, good luck with that. I hate drawing those. Alright. Example 3. And exercises A through E, and you'll see lots of these. I know they give you about 10 of them, but because usually they don't want to give you a lot of pictures. Determine whether you can assume the statement. So here we go. Plane L, okay, that's the top plane. It's going up, it's vertical. And plane K, it's the horizontal one, intersect at PS. Yes. Okay. Points, let's see here. U, M, O are coplanar? Well, they're all on L. I say yes. For some reason, I have it in my notes no. I'll have to look that up. U, M, O are coplanar because they're not on the straight line. And they're collinear on the same plane. Angle QOP is a right angle. QOP. Yes, because see that little symbol right there? MQ is on plane L. No. Okay, now this is why I'm going to change that answer. M is behind it. See that dotted line? It's on plane K and it goes behind it. So there's a no here. And guess what? M is not. Gotta be careful. Look at those diagrams. Okay, because of the dotted line, it's on plane K and it's going behind it. PS and MQ intersect at point O. Let's see here. PS, MQ. Yes, that's definitely happening. There's your homework. Those are your standards. And I believe I have another page here of things just to help you summarize of what's going on. Of course, for some reason the pages won't separate. Symbolic notation. Okay, so for I wonder why I have this on here. We already did these, didn't we? So, any case, you don't need that page. Everybody, have a good night. And, I mean, it's always important to remember these, but have a nice evening.